Assalamualaikum warahmatullahi wabarakatuh. We are from section EB2. We are going to present our project, which is application of polar coordinates in engineering and physics for subject mathematical method 1. For introduction, polar coordinates are another form of coordinate system that defines the location of a point by measuring its distance from the origin, an angle made with a positive x-axis, as opposed to Cartesian coordinates. The main advantage of the polar coordinates is their usefulness in defining rotational. Polar coordinates find extensive application in both engineering and physics. Engineers use them in the analysis of rotating system, robot, circular geometries, and flow through pipes, while physicists use polar coordinates to study circular motion, planetary orbits, electromagnetic fields, and waves.
So hi and Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Alisa binti Muhammad Nazri. So today I'm going to explain about briefly explain about background of study, which is I will do some research about parametric equation, polar coordinate system, and curve sketching. Okay, so for parametric equation, we got that parametric equation express both x and y in terms of parameter, usually t. So we got that x equals to x t, and then y equals to yt. So as t change, the coordinates x and y form a curve. So commonly it used to describe motion, trajectories, and also complex curves. So for polar coordinate system, we got r and also theta, which is the polar coordinate system is especially useful for describing circular, useful for spiral and also radial patterns. So we can see that many curves that appear complicated in Cartesian become more simpler when expressed in polar form. So next is curve sketching and also parametric equation. So we got this 4 steps we need to use, which is first step is choose several values of t, calculate of the corresponding values of x and y, and also plot the points x and y, and lastly is connect the point according to the increasing t orientation. Next, I'm going to explain about relationship between Cartesian and also polar coordinates. So first we have the equation for conversion between Cartesian and polar forms, which is we have 4, which is x equals to r cos theta, y equals to r sin theta, r squared equals to x squared plus y squared, and then last one is tan theta equals to y over x. So for the conversion between Cartesian and also polar equation, we got first and second, which is the same how we can do to if we want to do the conversion from Cartesian to polar, also polar to Cartesian, vice versa. So we got to replace r equal and r theta using the same relationship to obtain the Cartesian equation. So for intersection of polar curves, we got 4 steps, which is the first one is equate the two polar equation. Second is solve for theta, and third is find the corresponding value of r, and the last one is verify both equations represent the same point. Okay, so for next I'm going to explain about graph sketching of polar coordinates. We got 2 methods in this course, which is first method is using table, and the second method is test of symmetry. So the first one we can actually how we can do the method 1 is by select the values of theta, calculate r, and also plot the points r theta and connect the points. So we got the Cartesian, we got the polar coordinates. And then the second one is method 2, which is we need to test of the symmetry first. So we got 3 test, which is symmetry about polar axis, which is x-axis, and also symmetry about y-axis, and also the last one is symmetry about the origin point. So the first one is x-axis, which is replace theta with minus theta. If the equation remains unchanged, so the graph is actually symmetry about the x-axis. So the second one is symmetry about y-axis. So we can replace r theta with r pi minus theta. So if the equation remain unchanged, so the graph is actually symmetry about y-axis. So the next one is symmetry about the origin. So replace r with negative r, or replace theta with theta plus pi. So if the equation remains unchanged, so the graph is actually symmetry about the origin. So next is example of polar coordinate shape. This is the example that we can see most likely that we learn from our mathematical methods, which is we have circles, limacons, roses, and also lemon cakes. So in these are the how we can actually shape and remember the equation if given for us.
Moving on to sample problem 1, where we need to find the Cartesian equation from the parametric equation and to determine the maximum point of the curve. To find the Cartesian equation from the parametric equation, we first need to eliminate the parameter t from the parametric equation. We express t in terms of x and substitute it in y. So we will get the value is equal to negative 1 over 80 x squared plus 2x. We can determine the maximum point of the curve by using the derivative of y is equal to 0. By equating the derivative y is equal to 0, we are able to find the t for the maximum point. We will get the t is equal to 4 seconds. And substitute t is equal to 4 into the x and y equation, so we will get the maximum point of the curve is at 80 and 80. Moving on to simple problem 2, where it is related to polar equation. Given the Cartesian equation, then we need to determine and convert the equation into polar form. For the solution, using the polar form identity where x is equal to r cos theta, y is equal to r sin theta, and r squared is equal to x squared plus y squared. Substituting the polar identity into the Cartesian equation, we will get the equation of r squared minus 6r cos theta is equal to 0. Then we will expand the equation, then factorize the r, we will get the r times r minus 6 cos theta. Then we will solve for r, where r is equal to 0 and r is equal to 6 cos theta. We neglect the r is equal to 0, so our polar equation is equal to r equal to 6 cos theta.
Now I'll continue by explaining sample problem 3, which is about the intersection of two polar curves. The equation are r is equals to 2 for rather 1 and r is equals to 4 cos theta for rather 2. First, we test the symmetry of rather 2 replacing theta with minus theta. Since the cos minus theta is equals to cos theta, the equation remains the same. So the curve is symmetric about the x-axis. Next, we find the intersection by setting of the two equations equal, giving 2 is equals to 4 cos theta. Solving this, we get cos theta is equals to 1 over 2 and theta will be pi over 3. Substituting this value into the other equation, r is equals to 2. Therefore, the intersection points are 2 pi over 3 and by symmetry will be 2 5 pi over 3.
Okay, now we are at visual graph part. As you can see here, we have graph from Cartesian equation. This parabolic graph is obtained from Cartesian equation. We obtained from problem 1. Okay, as you can see, this graph form a shape sort of like a frown. And from that graph, we can obtain the maximum point, which is at x80 and y80 when t equal to 4 seconds. As time increase from 0 to 4 seconds, x increase steadily, while y also increase. But after the 4-second mark, x continue to increase while y began to drop. This graph represent the projectile motion. Now we are at the second example of polar graph. As you can see here, we only have one circle-shaped graph. The shape of the graph circle following the polar equation from problem 2 from the previous part. Or this is the equation r equal to 6 cos theta. The center of the graph is at 3, 0, with the radius of the circle is 3 unit. This graph is shifted to the right because the equation contains cos that shifted the graph to positive axis. It is symmetry on x-axis. We can test the symmetry based on the method explained previously. Okay, here we have the third graph for the example. Okay, the graph is intersection of polar coordinate. As you can see here, we have two circles, and the first circle have the equation of r equal to 2, and the second circle have the equation of r equal to 4 cos theta. Okay, the equation 1 is a circle with a radius of 2, and the center of the circle is at the origin of the graph. And for equation 2 is a circle with also the radius of 2, but the center of the graph is shifted to the right at 2, 0. The figures show that the graph have two intersections, that is 2 pi 3 and 2 5 pi over 3. Okay, both graphs have symmetry on the x-axis, as you can see from the graph, because on the positive y-axis and the negative axis, the shape of the graph is similar.
Next, I will explain the real-life application of polar coordinates. The first application is in navigation, GPS and radar systems. These systems determined by the position of an aircraft or vehicle by measuring its distance and angle from a fixed reference point. This information allows air traffic controllers and navigation systems to accurately locate and track objects in real time. The second application is in astronomy. Scientists use polar coordinates to describe the motion of planets, stars, and satellites because these objects naturally move in circular or elliptical orbit around a central body. Using polar coordinates makes it easy to represent and analyze their motion. The third application is in engineering and robotics. Engineers apply polar coordinates when designing circular structures such as domes, storage tanks, turbines, and rotating machinery, as they simplify calculation involving circular geometry. In robotics, robots and drones use distance and turning angles to navigate efficiently and reach their destination accurately. Lastly, polar coordinates are also used in geophysics to study the propagation of seismic waves from an earthquake epicenter. Since these waves spread outward in all directions, polar coordinates provide an effective way to estimate the affected area. In conclusion, polar coordinates are more than just a mathematical concept. They are a practical tool that is widely used in science, engineering, transportation, and technology to solve real-world problems and improve the accuracy of calculations involving circular and radial motion.
My name is Nur Nabila. So in conclusion, this project helps us to understand how parametric equation and polar coordinate can be applied to solve engineering and physics problems. We successfully learned how to convert Cartesian and polar coordinate, determine the symmetry and intersection of polar curve, and interpret the result using a graph. We also discovered that these mathematical concepts are widely used in a real-life application such as radar system, navigation, robotic, astronomy, and engineering design, where circular and rotational motion is involved. Overall, this project has improved our mathematical knowledge, analytical thinking, and problem-solving skill. It also shows that mathematical methods are not only theoretical, but are essential tool for solving practical engineering problems. So thank you for your attention.